Alrighty. So, as a reminder, we kind of talked through this yesterday, but I wanted to talk through it again because it's kind of weird to wrap our brains around. And that's the idea of a radian as a unit of measure. So, what this does is this bases our angles off of kind of a ratio. So, if we take our radius of this circle and we measure that same distance around on the circumference, this angle is 1 radian. So it's looking at the measurement of the angle here. If I measure 2 radiuses, so that same R, and we go again, that same amount of length. So this length was the same length as this length, which is the same length as this length. This angle is 2 radians. Because it's relating this measurement here to the length of the radius. And again, if I do that one more time, we get over to about here. Again, this segment is that same length as all those radiuses. We'll go with it. And so this angle has a measurement of 3 radians. It's relating the partial circumference to our radius. We talked about it yesterday, but the entire circle, if I went all the way around, it would be 2 pi r. But since it's in units of r, it's 2 pi to go all the way around. 2 pi r for circumference, right? So this is our angle 0. This is also our angle 2 pi. It goes all the way around. So halfway through is the angle pi. So a straight angle, a 180-degree angle, is the same thing as having a measure of pi radians. So 180 degrees is the same thing as pi. And that's how we're going to start with working with radians, is we're going to do like conversions, kind of like how we did degrees, minutes, seconds, but now we're going to go from radians to degrees and degrees to radians. Yes, dear?
What did that say? 2 pi or what?
So this one right here?
Yeah.
That's 2 pi, correct.
2 pi. Also, for measuring the radius, is there going to be like a way we like measure specifically so I can approximate it?
What do you mean?
Like, because I know you measured out like the radians for like...
We are, for the most part, going to be, it's going to have pi in them almost every time. So very rarely will we wind up with something actually being measured 1 radian. We'll be looking mostly at, and we'll see it here in just a little bit, partial angles, and we'll be talking about them as angles as opposed to based off the radius, but that's where radians come from. And without this, it just kind of winds up being one of those, it's magic, and it came from somewhere, and I don't know why, but we're doing the thing because we were told to do the thing. I try and fill in those gaps when we get there, so it's not magic. We did the thing because we were told to do the thing. Okay, so sometimes I give you guys filler information, and you're like, why? That's why. So we know where things come from. Connections. We love them. Mostly what we're going to do is we're going to start with looking at some angles here. So if you want any of those circle graphs, I do have more of them. I'm going to sketch these angles just all on the same graph. So I have some more of these circles. I'll toss a few of them out on the tables just so you guys can have them. Again, there's glue sticks and scissors in the boxes. We're not going to do tons of them, but I've got them if you want them. I would rather provide you guys with too many graphs than not enough graphs ever. So you do not have to use these, but if you want to, they're there, and then you don't have to kind of freehand it. All right. I'm going to do all 4 of these angles on the one circle. So important things for us to have on here would be those pieces that we just kind of figured out. This is always kind of our initial starting position, right here on the x-axis. So this is our home base. So this is where we start with 0. We also said if I go all the way around, this is also called 2 pi, because 2 pi r. It's always relating to the radius. Which means over here, halfway through that circle, is where we have pi. I'm going to draw that pi a little bit better because it's nasty. Pi. So if this is 0 and this is pi, what might this part be? Half of pi, which we tend to write as pi over 2. So what's this one down here? 1.5 pi. I'm going to do that as an improper fraction though, so it would be 3 pi over 2. Okay, so you know where that comes from? So let's look at our first set of angles over here. Pi over 4. Where might pi over 4 be? It's going to be less than pi over 2, more than 0, and pretty much halfway between them, right? This guy, ooh, I'm so good at drawing straight lines. This guy right here, halfway between 0 and pi over 2, is where we're going to have pi over 4. Because this would be the same thing as 2 pi over 4, right? What if we look at 4 pi over 5? Yeah, it's going to be closer to pi. Ooh, I should not have that be pink. I had my initial position be pink. So, sorry, I'm just changing the color. Be purple. So it's going to be close to pi, but not quite past it. If I divided this half of the circle into 5 pieces, it would be 1 piece left. So it's going to be kind of like, whoa, that was terrible. There-ish? We're eyeballing it. We're getting close. We're getting the vibe of these. Whenever it says sketch, do not stress about it. It's the vibe, not close. Like, I mean, close, but not rulers close. So this would be our, what's up? Is 4 over 5 more than 1? There we go. If it was 6 pi over 5, it would be down here. Because we always start from here and we count up because we're positives on these ones. Hello. Thank you. That was a choice. If it ever does that and I don't notice, please let me know. Because these two things have just been arguing all week. Neither one of them wants to be here doing any work. All right, so let's look at this one. We've got a negative angle. So that means instead of starting and going up, we're going to go down. So where is negative pi over 3 going to be? Negative. So it's not going to be between pi over 2 and 2 pi. We start at this pink line, starting here, and we go down 1/3. So this is 1/3 of pi, right? So it's 1/3 of our half circle. If it helps, you can totally write it like that. Negative 1/3 times pi. It means the same thing. We just typically don't write our radian angles like that, but it means the same thing. So if it helps you to think of it as 1/3 of the half circle, at least for now, you can still do that. So 1/3, there-ish. We went this way because it was negative. This is our negative pi over 3. one last one like this, and then we'll start comparing degrees and radians to each other. Where are we going to have 3 pi? It's where pi is at. So we go 1 pi, 2 pi, 3 pi. It is coterminal with pi. We just did a twirl. This is also 3 pi, which means if I kept going, I could get to 4 pi over here, 5 pi, 6 pi. Like, we can keep going forever and ever and ever. It goes all the way around. It's just spinning in circles. So it's, yes, dear. Half of the circle is 1 pi. 2 pi gives us a whole circle, because you can always think of it as our circumference. It's 2 pi r. Radians is r. Radians is in terms of r. So it's 2 pi, no matter what our radius is. That gives us our angle, because the angle doesn't change no matter what our radius is. The angle stays the same. I can draw my angle really little, or I could draw that same angle really, really long, and it doesn't change our angle itself. These two angles have the same exact measurement. The only thing that changed was the radius. So radians, the angle itself doesn't matter, or the radius itself doesn't matter in terms of the angle. So 2 pi r is not playing an effect on the angle. 2 pi gives us the whole way round. And it's just one of those things, it's just going to take some time for us to get used to. I know it feels super awkward right now. By the end of the semester, you'll be like, oh yeah, radians, whatever. Because we use them that much. A lot. So what we're going to start with is we're going to start with taking degrees and converting them to radians, and then we'll take radians and converting them to degrees. Because they're angles, I can use whichever measure we need to, but there's going to be times when things need to be in one form or the other. So when we're working with degrees, it is super duper important that you have our little degree symbol here. Radians doesn't have a symbol. You do not have to write out the whole word radian. You don't need to put R or rad or anything like that. It's going to be one of those. If it's not a degree, it's a radian. So we're going to use the fact that 180 degrees, I'm so good at words, is the same thing as pi. Pi radians is 180. That gives us our straight angle. That's half of the circle. So if I take 50 degrees and I want to find out what that is in radians, again, we're going to do this like a unit conversion. If I take 50 degrees and I want it to be in radians, we know that pi goes into 180 degrees. Pi radians over 180 degrees. That lets my degrees cancel out. And it's going to give us our radian measure, and it's going to be kind of gross. So I'm going to start by just straight up multiplying across. We're going to have 50 pi over 180. We multiply across. Does that simplify?
Yes.
How can I simplify that fraction?
Divide both of them
By 10. So we're going to have 5 pi over 18. Does 5 over 18 simplify any further? No. We will not be putting them into decimal. We're going to have pi's in it. Almost every radial measure, and I only put the almost in because I cannot 100% guarantee, but I do not recall ever seeing one. Almost every radian that we have is going to have a pi in it somewhere. It'll be incredibly rare that we do not have a pi. We will talk about pie lots and lots and lots. If it makes you hungry, sorry about you. All right, same vibe with the others. We're just going to convert these over. So our negative 75 degrees, we're going to do the same thing. We're going to multiply it by our pi over 180. And that's going to give us our negative 75 pi over 180. Our degrees cancel out, and then we need to simplify. What can we do to simplify these ones? You can divide by 5. I was going to say you can divide by bigger than 5, though. Or you can divide by 5 and then do it again. I just don't have it.
Divide by 15.
You can divide by 15. So you could do by 5 and then by 3. So if you divide by 15, then we get our negative 5 pi over, and 180 divided by 15 is 12. So we can simplify them. But again, they're gonna have pi in them. All right, one more this direction. So we're gonna take a 215, same vibe. We're taking our 215 times pi over 180. At our 215 pi over 180. And what does that simplify down to?
43 pi.
Mm-hmm. Gorgeousness. 43 pi over 36. So they're not pretty. We still wind up with pies and fractions and kind of icky looking things. But that's how they look. Okay. Questions on these three? Because we're about to head the other direction. We did degrees to radians, now we're going to do radians to degrees. Same kind of vibe though. So we're going to convert from radians to degrees. So I'm giving you radians here, and it's the same vibe, it's just a little bit flipped. So we've got 5 pi over 6 as our radian measurement. We have 5 pi over 6. And I want to have degrees, so when we do that unit conversion, I need to make sure we have our degrees on top. I need to wind up in degrees. Our radians are going to cancel out. So if we have 5 pi over 6 times 180 degrees over pi, what's going to happen? My pi's can cancel out. And we're going to get our 5 times 180, which gives us 900 degrees over 6. What does that simplify down to be? 150. So 150 degrees is the same thing as 5 pi over 6. It's two different ways of writing the same angle. Okay, not too bad calculation-wise. We can do these. We can do these. They're weird, but mathematically they're not too awful. So 3 pi over 4, same vibe. 3 pi over 4. We're going to make our 180 degrees over pi. And you can simplify these in whatever order you want to. You do not have to do like the full multiply across and then simplify. You can simplify as it is right now if you want to. Well, we notice that 180 does in fact divide by 4. What do we get when we multiply this fraction together and simplify?
135.
135 degrees. Super important to get that degree symbol on there. That's how we know it's degrees and not radians. So you gotta put that degree notation on there. Okay? One more like this. So we've got our negative 3 pi over 10 Converting this to degrees, we take our 180 degrees over pi. What do we get when we simplify this one?
Negative 54.
Gorgeous. Negative 54 degrees. Okay? Not too bad. They seemed way scarier yesterday. That's why we talked about them for a couple of days. Reasons. All right, so we're gonna keep working with radians because honestly, we're gonna live in the world of radians a lot this semester. So yesterday we did our, oh my gosh, words have entirely left me. Our coterminal angles where we had one that was positive and one that was negative, and we found our complementary and supplementary angles. Those were the words that left my brain entirely. So we're gonna look at positive and negative coterminal angles again, and we're gonna convert these from one direction to the other. I guess I didn't include our So looking here at 90 degrees, we are familiar with 90 degrees. What is 90 degrees going to be in radians? Pi over 2. Those two things mean the same thing. So when we're looking at coterminal angles, you can do it in degrees or you can do it in radians. So if we think about our 90 degrees being this guy here, when we started here, I'm going to make that purple a little bit brighter so we can see it. Oh, there we go. So this is our angle that we're looking at. What are some coterminal angles for 90? I could go wrong way round. I could go this way and get to negative 270. So when we do, to get to our negative, because I've heard the question in two places right now, we can take our 90 degrees minus the 360 degrees to get that negative 270, to get that negative coterminal angle. Our positive one, I heard one over there that was our 90 degrees plus the 360. That's going to give us a positive coterminal angle of what? 450 degrees. What if we did it with the radian measure? What if we took our pi over 2 and I wanted to get the negative that would get me there? I don't want to do minus 360 because that would be degrees. So if I minus the whole circle, what is the radian measure for the whole circle again?
2 pi.
The whole circle is 2 pi. So if I take pi over 2 and we subtract 2 pi, this would be negative 3 pi over 2, or negative 1.5 pi, but that feels so strange to say for me. Yes, dear?
For that equation, the first one is positive and minus 2 pi. Would that be?
You check
Yeah.
this one here?
Yeah.
So it would be setting it up like this.
Okay.
Pi over 2 minus 2 pi, that gives me the negative. That's giving me this one, this same angle, but in radians. So if I'm looking for a positive coterminal angle from the radian measurement, we would take our pi over 2 and add 2 pi. Oh my gosh, I'm getting like 12 emails right now. So what would our positive? Say it louder. Yeah, 5 pi over 2. And it's just one of those things with radians. We always kind of do them as these improper fractions. We won't write them as mixed numbers. It feels super weird to say it as like 1.5 pi. It feels so wrong to say it like that. So we always do them as these improper fractions. It's just one of those things that makes it easier when we're looking at actually doing the trig stuff with them. Oh my gosh, so many emails. If I get 2 more, I'm going to have to take it off. It's making my work tickle. Okay, so let's do the same thing with the 8 pi over 5. So 8 pi over 5, let's put this as degrees. What is this one in degrees? Take a second for that one. Because we're doing totally fine that time. Yes. It is 288 degrees. Anyone see how that happens? Okay, cool. Just checking in. If y'all are quiet, that's okay. Totally get it. Just checking in. So we'll do our coterminal angles in radians, and we'll do our coterminal angles in degrees. So we're going to take our 8 pi over 5. Oh, they've decided to mop the floors right now. Yes, dear. Yeah, right to pass. Okay, so if we're looking for our negative coterminal angle, that's when we're going to subtract the whole circle. So we're going to subtract our 2 pi. What are we going to get when we subtract 2 pi from 8 pi over 5? Yeah, so if you don't type it in the calculator, we can do this by common denominator. So it would be 10 pi over 5, 8 pi minus 10 pi gives us negative 2 pi over 5. So that would be a negative coterminal angle. To get a positive coterminal angle, we're going to take our 8 pi over 5 and add our 2 pi. Go around the circle the other direction. What's up? Okay. I have 100% no problem with people with us asking questions. I love for you guys to ask questions. Totally fine. So what are we going to have? 18 pi over 5. I was like, you went a whole nother time. Because 2 pi, if you think about 2 pi being 10 pi over 5. Two pi is the same thing as 10 pi over 5, right? So common denominatoring, we'll work with it here. So then let's do it in degrees. Find our same kind of vibe on the 288. So 288 degrees, if we're looking for that negative coterminal angle, that's when we're going to subtract our whole circle, which is 360. So what is our negative coterminal angle for the 288?
Negative 22.
Just double checking if I didn't actually write it down. Negative 72. And our positive would be 6 what? 648. So, sorry, let me write it down. So our 288 degrees plus 360 degrees gives us our, and I've 100% forgotten already. Okay, so 648 degrees. It is super important that you get those degree symbols on there. When we're dealing with degrees, you got to label them as degrees. Super duper important. Otherwise, we're in like 648 radians, and that's going to loop around a whole bunch of times. Okay, so with these radian measurements, we're going to have two formulas we're going to use for the rest of today. And that's going to be relating our radius and our angle into other pieces. Like this, we've got two formulas. We've got an arc length, so it's the measurement of that side of the circle, and the area of a circular sector, so a pi wedge. Now what I've done, with a knife, I printed out the word parts. I mean, it's all much easier. You have to cut them apart if you want to separate it. But that way you don't have to like try and rewrite paragraph part. If we ever have like super wordy problems, if it's more than one, I usually print them out for you. Just because some of these are really wordy and we need like 3 things from the sentence and I don't want to take 3 minutes to write the whole sentence when I need like 2 numbers out of it. Okay? So these are the rest of the questions we're doing today. Once we get to the end of this, we're done for the day. So these 2 formulas are not on there. So you need these 2 formulas, our arc length and the area of a sector. Now what that means is if we're looking at the circles we've been working with, so thinking about this guy here, we're starting on our x-axis just like normal, and they're going to give us an angle. That's theta. The arc length is this. It's the measurement of the little blue piece right here. And we call that S. It's the length of the arc. The area is the pi wedge. Whoa, chonky pen. This guy. So our area is the area of that piece. Okay? So there's a very strange word inside these sentences where it says the circle of arc 10 centimeters subtends is part of, holds, contains, is what that means. Subtends just means it's the angle that has that measurement. So this is giving us here a circle arc of 10 centimeters. So they're saying the S. That is the measurement of the length. That's this guy. So S equals 10. And they're giving us our theta of 5. Oh, there we go. I was going to be like, I have a different thing written down. So this is our angle. And we are asked to find R. So we're going to use this little formula over here to find it. So we're going to have S equals R times theta. So we have 10 equals our R, which we don't know yet, times our theta of 5. What does R equal?
2.
2. So the radius of this circle is 2. Okay? Super complicated, right? Ooh. One thing that's super duper important in these formulas, and I forgot to mention up here, when we're looking at this, it makes a difference whether it's in radians or in degrees. Theta in formulas has to, not optional, not negotiable, must be in radians. Must, non-negotiable, non-optional, has to be in radians. Okay? Yes, I am sure about that. My master's courses require that. So our theta has to be in radians when we are using these formulas. I'm gonna write it in radians. I meant to say it at the top and I forgot. So R is our radius, theta has to be in radians, and we're going to go from there. So then on this next one, we have that our circle has an arc of 24 feet. So they're again telling us the S. So this guy is our S. Our theta is 34 degrees. Well, I just reminded us, theta doesn't get to be in degrees. It has to be in radians, so we have to convert it. So we're going to take our 34 degrees. And how do I make this be in radians? Divide by 180 and multiply by pi. And that's going to give us including simplification. Yep, 17 pi over 40. Was that? Oh, is it 90? It's called I can't read my handwriting sometimes. That makes more sense. Yeah, that is a 9. I just have a weird gap at the top. All right, so that now gives me my theta. This is the theta we can use in the equation. So we have our 24. What's up? What's your question? Mm-hmm. This one already is in radians. Okay, so it has to be in radians. So we're substituting our pieces in. 24 feet is r times 17 pi over 90. So what can we do next? Multiply by 90. That's going to give us 2160 equals r times 17 pi. Divide by 17 pi. So r equals 2160 over 17 pi. Great. How far is that? Give me the 2 decimal places. Actually, give me a number. When we're looking at the radius, we're trying to find an actual measurement. I need a measurement and I need units. 40.44. What's our unit? Feet. Okay. Questions on these two? Let's make sure we get to one that has an area. Cool, cool, cool. All right, so this one is finding the length of the arc, so it's going the other direction. We're going to find S. Finding the length of the arc. So we're going to find S. Equals our radius of 9 centimeters. Which is this guy here. Times our theta. But remember, theta has to be in radians. What is 60 degrees in radians? We got this. Pi over 3. Keep the pi in there. Don't switch it to decimals except on things like radius. If we need, like, if it's a straight line, great. If it's an angle, keep the pi there. So this is going to be a pi over 3. So we have 9 times pi over 3. The only time we're converting to actual decimal numbers is if we're looking at a measurement, like a length, side length, or radius length. So what is this simplified? What is the length of this arc? 3 pi. So again, it's a length. What is 3 pi? As a length. Say it louder.
42.51. Oh wait, sorry. 41.
Because y'all went way too big. Why'd you square it? You did area. We're finding the length. We're on the left one. S. So 3 pi is going to be 9.42 centimeters. Okay, so substituting in for these guys is pretty much the same. Got like 2 minutes. So we'll just do one of them real fast. All right. So our S is 10 centimeters. Our R is 2.5 centimeters. We need to find our degree for our rate. Actually, no, we got a minute. Let's do this one tomorrow. This is the very end of 6.1. So you guys can honestly probably figure it out. But if you are stuck on that on the homework, if you need to turn the homework in on Monday, I get that because we haven't gone through the area one. But that's the vibe. This is the very last section of 6.1. But I was like, I'm not going to speed run it on this one.